So in 2008, I watched a video by a guy called Carl Paulsness of his replication of the Tesla hairpin circuit, which is also known as the Lecture arrangement, because it was invented by the Austrian physicist Ernst Lecture in 1888, and Tesla built a variation of it, and he first mentioned this in a lecture in 1891. And what fascinated me about the Tesla hairpin circuit is, because it's a high voltage and high frequency device, it has this incredible ability to be able to light a bulb underwater, and you can even hold the conductors without receiving a shock. So that prompted me to try my own replication. So the circuit diagram is remarkably simple. Basically you have some thin, tall conductors, either copper or a cheaper solution is aluminum. This diagram shows the 10 millimeter aluminum tubes, and you want an incandescent bulb as a load to demonstrate that you're actually generating some current. In this case I used a 12 volt 50 watt halogen bulb, and it's connected with some just copper wire I had lying around. The capacitors I used were 40 kilovolt 2000 picofarad, what they call doorknob capacitors, and the power source was a 9 kilovolt neon sign transformer rated at 30 milliamp, and of course there's a spark gap there as well. I used some tungsten rods specifically designed for spark gaps, but you can get away with just using some screws lying around or some nails. Incidentally, this is not an optimized, tuned or resonant circuit. This is just what I had and what I managed to make work. The Tesla hairpin circuit is so named because once it's built, it resembles a hairpin, but apparently Tesla never actually called it that. Instead he referred to it as simply stout copper bars in his 1893 lecture. Now Tesla's design of the circuit differs from Ernst Lecture's original design, and that while Lecture used his device to study resonance phenomena, Tesla was more interested in studying impedance phenomena and demonstrating how high frequency currents pass through conductors or stout conductors such as copper tubes. For a more in-depth understanding and also how to achieve resonance with the circuit, you can see Nick Crackman's excellent articles and videos, and also Wikipedia has some info about the lecture arrangement or lecture lines, which were used primarily as an early means of measuring the wavelength of radio waves at ultra-high frequency and microwave frequencies.